Hey everybody, it's Scott, Simcoe Spring Service, and today I'm going to be doing a tool upgrade. So the current tool I'm using is a 5/8 jobber drill bit. It's pretty simple, and these are the blanks that we're using. So all we're doing is we're coming in with a smaller drill bit first. We're gonna drill a hole in it, and then we switch out to the 5/8 drill bit, and then we do a follow through to open up the hole to the final size and dimension. This is currently taking a fair amount of time. So we're trying to do a tool upgrade today to do it in one drilling, and on top of that it's going to be a carbide insert. So it's supposed to be cutting faster, it's going to be at a higher RPM, and it'll be just quicker in and out, and it should be done in one pass instead of two. So there's no tool changing involved and stuff like that. So basically I'm just trying to produce these things quicker. We're trying to be more efficient and trying to cut down on just time spent, because right now it takes us we can make about 100 a day if everything goes perfectly. So we're trying to increase that to 200 a day, so then that way I can double my efficiency, and if it just costs me a drill bit and a setup, then it's well worth it for an investment. So I'm always looking at different ways to improve my efficiency, because if we can be faster, we can make more money, it's more profitable, I can pay my guys more, it takes less effort. So it's a win for everybody. So essentially what I'm trying to do is just be able to create as many products as we possibly can in the shortest period of time, while keeping up the quality within a few hundred thousandths of an inch of each other, so that every single product that comes out is almost identical, but very quickly. So always looking for ways to improve my efficiency. So I'm gonna have Jim Brown come down from Just in Time Tools out of St. Thomas here in Ontario, Southern Ontario, and he's gonna be able to help me upgrade my machine. We're going to run a few passes. We're going to try to see what kind of efficiencies we can get out of it, because every single machine is different, every single tool is different. So as we combine the tools and the machinery and the harmonics and the RPMs and just the way the coolant flows and stuff like that, we're going to see what kind of efficiency we can get out of it. And we also have to worry about durability too. So if we can produce more product in a shorter period of time, then it's a win-win-win. So we're gonna go throw some of these in the CNC machine and see how they turn out. All right, so let's see what we got in here. We got a wrench for tightening it. All right, so that's a collet. Look at that. That's our collet there for holding onto the tool. There's my collet holder. This is a BT30 tool holder. This is an Ingersoll cutting tool. So that's my actual carbide insert holder. So that'll hold the insert in there. And we got a short stubby one because we're only going to go through 1/4 inch of material. So this one is specifically for my 3-inch blocks. There's our Ingersoll cutting tool. Oh, it's just a little guy. So there you go. So that'll slip right into here, like so. There should be a little installer somewhere. Here's my little holder, it goes in here. That's actually bolted into the machine itself. Let me go find my little installer tool. It must have fallen out somewhere. Jeez. Should be like a little tool that clips in here and like locks it in place. I'll go find that. Must fallen out of the box. So I found my tool. It was inside the case. So we just stick her in there and we give her a twist. And it should lock in place, just like that. So, just tightened with my ratchet that I don't have. There's a special socket that I use for tightening these. Just give it a torque. That loads into there. Take my specialty tool. Slides into there. How deep do you want this?
Yeah, right about there is good.
Right about there?
Perfect.
Still learning myself
Yeah.
how to do this. And then we crank it on.
Yeah, you want it fairly tight, eh?
A little bit tight. So there you go. That's ready to go into the machine. All right, so we're gonna drill and work offset. It's gonna be G54.1 T13. Spindle RPM, you want 1,750?
Yep.
That's the fastest I've ever run this machine other than into wood. Z feed rate.
What did I tell you there? Oh, that.
There's 11.
Was it? Yeah, that's good.
11?
Yep.
All right, we're gonna send her full more. Z clear, we'll do 0.5. So we'll go half an inch clearer whenever we move positions. We're gonna do full flood coolant.
Mm-hmm.
No packing.
Nope.
And gonna be a full send.
Yeah.
Z start will be 100 thou above.
Terrific.
And Z end will be, well, it's 1/4 inch thick.
Yep.
And
You can do like, if you want to penetrate a 1/4 inch. It's,
so minus 0.5. You like that?
Sure.
See how it ends up?
Yep.
Gosh, I am not nervous at all about this at all. Now, do you want to start this at +2 and then go down to +1.5 so we don't crash it? We do one in the air first.
Oh, yeah, we can absolutely do that. Cool.
All right, here we go. We're gonna attempt this. We're gonna cut it in the air. We're gonna see if it works. We're basically just looking for tool pathing to make sure it's all correct. And once the tool pathing is correct, we'll go and reprogram it and make sure that it actually goes into the metal this time. So this is just in the air as a test piece to make sure it doesn't crash. We're gonna stop that. Okay. So we have to adjust at least one of these to make sure it actually is blowing on the tool. That is so fast. That is so fast. All right, one more try. That's so quick. I can't even open the cabinet.
Can you put cycle hole or something?
God, it's so quick.
Now, is that the proper, is that our RPM we're looking, or are we?
That's just the velocity of moving from point A to point B.
Okay.
Once it gets to its location, then it'll spool up. So I can turn up my velocity to 100%. I've never run it 100. I usually run about 70.
Sure.
But this is how fast it moves. See how fast it goes down? So it's just it's hard to get the coolant into it.
You know what, I mean, it's not so important on this hole, it'll be more important on deeper holes.
Yeah. But then we'll have a longer bit to go down the deeper holes, right?
Sure.
So, and I can't move too many of them because they work with all the other tools.
Yeah. That's you're good there.
You want to try it?
Yep.
Okay. We're going to call that good enough, and we're going to go and reprogram it and run an actual true cycle. That is so quick. I am scared slightly, but it should work. Okay, so we're going to run the cycle, see how it cuts, and what we're going to be looking for is A, does it explode on contact? B, does it cut properly? I want to look at the exit point to see if it has any burrs or if it actually penetrates all the way through the material or it doesn't leave a ring at the bottom and I have to grind back out of it, because then I'll have to drill it in a little bit deeper to actually have the drill bit penetrate through the back of the material, and it'll be good or bad. We'll find out in about 15 seconds. Take my velocity down to 30 again. And this is so fast I just have to hit go and
Yeah, just go. We'll be all right. As long as your parts are clamped, we'll be fine.
all right, here we go. All or nothing. Didn't go up the back.
We don't have, how many horsepower is this?
Now, how do I get it back out of there? That's the real question of the day.
I've never had this.
So we'll take the part out.
With the axis.
We're going to reset. We're going to go to Z axis. So I think the speed is good, but the feed rate is not good.
Well, we can slow that down if we can salvage the insert.
Oh,
How many inserts do we bring, bud?
we have one insert.
Oh, see, that's so Ricky of me.
So we didn't get very far. We're gonna call that a loss. It's almost like I was ready for this. I don't think anything broke. No, it just overloaded the motor and spun. So I'm gonna take the tool out. It looks perfect.
Let's have a look here.
I don't think it's strong enough to break it.
You know, we're pretty fortunate.
I know.
Okay.
Well, what did I say about breaking every single thing that I attempt to put into the machine?
You didn't break that, buddy. You didn't break that.
So,
Okay, so let's look at our feed.
you want to cut that in half?
Yep.
6
Yep.
inches is still very quick. So before we were running at
11.
2.4.
Oh. Yeah, so that's 3 times faster.
So we're almost 3 times faster than what I was running with my old drill bit. Save. And it could be a limitation on the machine. That's pretty much it. If it was a stronger machine, you can get away with it. Yeah, there it is. So it should change it once I hit that. Oh. Like, where's my coolant? That sounded rough.
Yeah, let's have a look.
Seems to really grab a hold of it. I heard a chunk come off.
Yeah, let's look for some chips in there. Let's see what kind of chip controller we get. Looks good, eh?
Still got perfs on there.
Yeah. Looks good.
So as we're looking for chips.
It's a really light chip. I mean, I broke it. It's very, very light, easy to break. There's no heat in the chip.
Chip looks good. I heard a chunk. I wish I could slow the life down and look at it. You may see it in post-production. Pop this one out. See what it looks like. So big chunks coming out the back like that. But you said it's a lot flatter blade, right? So it's gonna... I don't know, I'm trying to pull a chip off. Okay, so we're gonna attempt this one here. So that one we drilled right through the weld seam. This one has a weld seam on the side. So we're gonna put this one in, see how it reacts. I heard it crunch, but I won't know what that is until I slow the video down and actually look at it afterwards. If I can even see it.
Let's back off the feed rate to 5.
That sounded like butter. That's the ticket right there. There's a chip. Woo! Look at that. It's like polished like a mirror. Hopefully I can zoom in and you can see that.
Nice. It's nice and springy. It's you know, at the recommended feed rate, that would short chip even further. We're really light on the feed rate due to horsepower constraints, but we're getting closer to the sweet spot.
Here's another one. So they're coming off in little chunks, so that's a good thing. So they're not all spooling up and spindling up into the bit, nesting, as I call it. Turning into a giant bird's nest.
So we changed 2 things there, right? We're not drilling through the scarf, and we slowed the feed down by 20%, and it sounded really good. So we need to drill through the scarf at this feed rate. See what it does.
Oh, you want to just move it over?
Yep.
Because that's the only 2 last ones I have that have the weld seam.
Okay. Well, let's drill a seam. If it don't sound good, then we know it's the seam causing.
Oh, look how clean that is.
Yeah, seriously.
It's like a little trash can lid. Alright, move this over. See if that feed rate works good for it, and maybe that might be our magic ticket to success. Yes, I weld seam. So the other option is, I don't know what the other option is. But it's essentially that weld seam is kicking my ass here.
But it's definitely going to leave a premature wear on that insert.
Right.
No question about it, eh?
So it's a weld seam that is kicking my butt here. It's a weld seam. It's 100%. So if I can get away from that weld seam, then I can do it, and that's fast. Because there's no pre-drill. There's no pre-drilled hole, so I'm saving tool change. I'm saving. So drilling one cycle at 2 inches per minute, 3 times. Tool change, another cycle of 2 inches per minute of drilling, and then a tool change, and then I can finally do my back end. So, all right, something to think about.
Mm-hmm.
But I think this is a path to success. I'm not disappointed or anything, so we'll go from there and keep testing it out. So I took a couple days to rewrite the program and try to make it a little bit more efficient. One of the issues that we were having was that I was trying to tweak the drill bit to actually match my machine. The drill bit can handle a lot more than what my machine can. So instead of trying to brute force it through, we took it a lot slower, and now we're trying to do a different run cycle to see what kind of things I can improve on. So what I'm going to do is I'll run a cycle right now with the most improved setup that we have done so far, and I'll kind of walk you through some of the things that we noticed that were a great improvement from one of the old processes that we used to run. So we're setting up a tool change here. So now one of the interesting things is the old cycle that we used to run was around 10 minutes long. So 10 minutes for 3 blocks is a significant amount of time. So what we're trying to do is cut that down. So you can see here, gosh, that's so fast. Pretty decent chip control. It's coming off there nicely. Already the second hole, you can see how fast that is. It's incredible. So cutting this cycle down to a quick speed for us is going to be crucial, because if we want to make thousands of these blocks for people and keep ramping up, then it's going to be an absolutely crucial part. Look at it, we're already done. Like, that's crazy how fast that is. You can see how it's kind of bird nested up on there, and that was the issue with the feed rate. So technically we could cut down on the speed a little bit as well. Yeah, you can see it's all like curled up on the side there. It's not necessarily like the best program, but I mean, look how fast that is. That's crazy. So when we're done the cycle, we'll just have to take a pair of needle nose pliers and like pull some of that off of there. But now we're already onto the second tool cycle, whereas before we would still be drilling the first hole. Like, it always just fascinates me watching the CNC machine do its cutting and stuff like that, because you can actually look at the process and see where your inefficiencies are. It's like, so should we get a faster drill bit for this? Should we get a longer carbide for this? Is this something that's slowing down the process? These are all the questions that you have to ask, and then can you come up with a solution to it? Because you can see those first 3 holes, if we could drill the second set of holes as fast as that first set of holes, we'd already be done the blocks. And yet we're still drilling and drilling. And I find it fascinating, because it's just like trying to figure out all those little ins and outs of the process on how to make things more efficiently. It just, like I said, it fascinates me. Okay, so we're done that cycle now, and we're going to be switching over to the tap. So in one of our older, let's wait till the tool changes here. It's a little annoying with the air. So with one of our old processes, what we did was we would weld the pins in, and it didn't work out that well because I find that welds can break. So with the new process with the tap, we can actually thread it into the block itself, and then when it's actually done, we actually weld it in as well. So it's threaded and welded, and I find that combination really works really well for like durability of that pin that goes in there. But yeah, so that's it. That's done. You're looking at about roughly 3 minutes and 15 seconds to complete the cycle. Like, that's a huge improvement. So there you go. So this is Jim Brown. Thanks a lot for coming down and showing me how to work this machine.
Anytime.
This is a little bit new for me. I'm still learning the machine. I've only had it for 6 months. He's been a lifesaver for helping me find tooling and stuff like that. We're working on efficiency, working on the limitations of my machine, because I got one of the smallest machines that you can buy because I'm limited on my electricity of 220 single phase. So he's used to running equipment that's a lot more robust. So a little bit of a learning experience for both of us. So thanks for following. I really appreciate it, everybody, for watching. Appreciate you for coming down and helping me figure this out.
Yeah, man. We definitely learned some things. We have a little bit of horsepower constraints with the machine, but we modified the feed rate from 6 thou per rev to 3 thou per rev, and yep. It seems like we have lots of horsepower with that. And eliminated some packing, eliminated a lot of cycle time.
Yeah, tool changing. So I mean, we could probably run all 3 of those holes in like less than a minute now. So before it was taking about 3.5 to 4 minutes. So we're at almost like 4 times our speed on this one. Hopefully 4, maybe 3, but even so, it's gonna be pretty awesome. So yeah. Anyhow,
we did consider an indexable drill. However, indexable drills use very, very small inserts. The insert screws are incredibly small and weak. This here is, the tip drill, nice and robust. You have the forgivingness of the high-speed body, the performance, the longevity.
Well, the only reason why it didn't break is because of the tool that he chose. So I mean, I can't complain about that. So
probably.
More than likely. Anyhow, thanks again. And where are you from, and who are you?
Jim Brown, Just in Time Factory Supplies out of St. Thomas, Ontario. We put chips on the floor and product out the door, right?
There you go. All right, thanks everybody. Have a good day. I'll catch you next time.